So here we have question 3, clearly dealing with some statistical work, where we're asked to find an unbiased estimate of both the population mean and the population variance. It'd be handy if you came to the question with some knowledge of those, but don't forget that on your formula booklet on page 5, you're given an awful lot of the information you're asked to calculate, so you shouldn't go wrong. You have your calculator. Let's go to the statistical page, move along to stats mode, and you're given a list. Let's input the data into that list. We're clearly taking a sample here of 8 items of data, so let's get them in and see what the calculator can do for us. You're going to have to explain to the examiners how you get an answer. It'd be unwise to just take an answer straight off the calculator. It will take one input error to produce a wrong answer, and therefore no marks. So be very careful. You check the data you input, that you have no mistakes on it, and you explain how you get the answers, or should I say how a calculator gets the answers. Right, first of all, we've got the calculator button. Let's press that, and we're dealing with a single variable here. Let's press F1. There's all the information we need. We have a value straight away. X bar equals 9.4625. But we want an unbiased estimate of the population mean. Well, even if you look at your formula book, you'll see the population parameters gives you some information there, and in the formula book it tells you that the population mean is sum of fx over n. Now you have to come with the knowledge that the best estimator you can get of the population mean is the sample mean. And of course this figure that we have on the formula book doesn't exactly look like the symbols we have on our calculator, but that's because this F refers to a group and a grouped frequency situation. On our calculator the equivalent is all the values are added up and divided by n, which is the same. So we can explain to the examiner how we got our answer. It will be the sum of x, 75.7, divided by 8. And that is our working for how we got the population mean. We haven't actually finished until we round it off. It's 9.46 to 3 significant figures. What about the population variance? Again, on page 5, we have some information on that. It tells us that the population variance, and if you look carefully, there are 2 figures given, and it uses something at the bottom of the page which is called an unbiased estimate of the population variance, and it is written like this. And that figure is calculated as the sum of fx squared divided by n minus 1 minus n all over n minus 1 lots of x bar squared. And again we have those figures. Our calculator does calculate the sum of all the frequencies times x squared, but of course on our calculator it's just given as the sum of x squared. N minus 1 is no problem, we can work that out. Subtract n all over n minus 1, and of course we have the figure for x bar, which has to be squared. So those are the equivalent figures on our calculator. Show the examiner how you would calculate it. The sum of x squared is 861.99. N minus 1, of course, will be 7. Take away 8 all over 7 times by the non-rounded figure for x bar, sample mean squared. And that will give us our unbiased estimate of the population variance straight out of the formula book. You can return to the calculator and work all that out, or you can remember that on the calculator that figure is given to you and it's under the symbol x sigma n minus 1. However, that is the best estimate of the population standard deviation. We want the variance, so it must be the square of that. So we could also explain to the examiner how we might get it. It would of course be 4.56193488. 9. I don't think that's necessarily working, but I've put it down for one good reason, because our calculator doesn't give us the variance, so we've got to calculate it. So let's go back out to the main menu, to run mode, and if I put that figure in, good point here, when we're doing this sort of work, it may be good in the exam to consider bringing a simpler calculator for this sort of work, so you don't have to leave your stats mode to do it. We square that, we get 20.8. And 20.8 is our best estimator of the population variance. So, in a nutshell, what should the examiner be getting? An explanation of how you get the answer that indeed the calculator does for you. And here, an explanation of how you get the answer that the calculator actually does for you. May well include this figure, but to be honest with you, the shaded bits, the highlighted bits, are enough for you to get full marks for this question, so much of it on the calculator and in the formula book.